Hey there, Mr. Weaver here, and this is Topic 7, Lesson 4, the greatest common factor. After this lesson, you need to be able to determine the greatest common factor within the terms of a polynomial, and you need to be able to factor out the greatest common factor from a polynomial. You'll know you're successful after this lesson if you can determine the largest monomial that can be divided out from every term, and if you can factor out the GCF of a polynomial and write it in the correct form. Here, when we're talking about greatest common factor, it's no different than what you learned in previous grades. It's the largest number, and this time, and or variable that you can divide out from each term. So when you're doing this, just think to yourself, what can you divide each term by and still have it come out nicely? As you are doing this, one thing you do need to remember is if the first term is negative, then that negative must be factored out. So for example, if you had negative 3x to the fifth plus 9x to the second, here we can see that first term is negative. So when I'm factoring everything out, I just need to make sure I pull out a negative as part of my GCF because that first term is negative. Finding the greatest common factor within the terms is going to be a pretty important skill that you're going to need to have. We're going to use it in this chapter to factor by the greatest common factor. So when we're doing this, and we'll go through examples later, you're going to determine the greatest common factor. Then you're going to divide each term by that greatest common factor or figure out what you had to multiply by. And then you're going to write your final factored form answer as the greatest common factor, GCF out front, then a set of parentheses with whatever was left inside after you divided. That's your quotient. So let's start with an example of what is the greatest common factor of 7x to the third plus 14x to the second minus 21x. Again, we are trying to figure out the largest number and or variable that you can divide out of each term. So I'm going to start, what number can all of the terms divide by? Well, I'm going to take those coefficients. So I have 7, 14, and 21. I'm not going to worry about so much if they're positive or negative, unless that first one is, then that negative comes in. It's not here, so I'm not going to worry about it. I'm going to go through and think, what are all the factors? What can you multiply by to get each number? So for 7, I can only multiply 1 and 7. For 14, I could multiply 1 and 14 or 2 and 7. And for 21, I could do 1 and 21 or 3 and 7. If we look through here, 7 is a common factor of all of them, and it's the largest. It is the greatest common factor for our coefficients. So I'm going to take note of that 7. As a side note, if there is not a common factor other than 1, then 1 is your greatest common factor. Now we're going to do the same thing with our variables. So what is the most of each variable that can be taken from every term? So here I'm only going to deal with the variables. I have x to the third, x to the second, and x. If you think about what exponents mean, it means that base multiplied by itself. So x to the third is really x times x times x. X to the second is x times x. And x is just x. What is the most x's that I could take from every term? Well, that last term, that single x, only has one x available to pull out. So I can only take one x from each term without them completely disappearing. A quicker way to realize is just looking at the exponents. The lowest exponent is going to be what you can take out. So here we had x to the first power. I could take out 1x from each term. for my greatest common factor, I'm going to put them both together. I had 7, and then I could take out an x, so 7x is my greatest common factor. And again, if that first term was negative, which it's not, then we would make our GCF negative. But since it's positive 7, we just keep it as positive 7. Now it's your turn. Pause the video. What is the GCF of 3x squared minus 12x plus 51? Let's check. You should have found the GCF is just 3. The coefficients 3, 12, and 51 all can be divided by 3, but not all terms have an x, so you couldn't take out an x from every term. So there is no variable in our GCF. The only thing we can divide each term by is 3. Let's look at another example. Here we have one that has 2 variables. So what's the GCF of negative 4x to the third y plus 12x squared y minus 24xy? Again, we're going to start, what can all the numbers be divided by? We have negative 4, 12, and 24. Here, notice, and it'll come back and play later, but that first term is negative. So our GCF answer needs to be negative. Again, I'm going to list out the terms. So for now, I'm going to ignore the negative. I just need to know that my answer will be negative. So 1 and 4 or 2 and 2. Right away, 4 is the largest. So I'm going to check, can the others be divided by 4? If not, I can go on to the next largest, which would be 2. So 12, can it be divided by 4? Yes, you would get 3. 24, can you divide by 4? Yes, 6. So the GCF here of our coefficients is going to be 4. And again, since that first term is negative, we need to take the sign, which means it's going to be negative 4. And what's the most amount of each variable that we can take from every term? So I have x to the third y, x squared y, and xy. If I wanted to write them out, I can see in that last one there's only one x to take, so I can only take one x from each term. In that last term as well, there's only one y, and I can check there is a y in every one that I can take. So my final GCF, I would take negative 4 and then 1x and 1y from each term. So negative 4xy. Now it's your turn again. What's the GCF of 3x squared z squared minus 12x to the third y z squared? Let's check. You should have found the GCF was 3x squared z squared. I can divide both coefficients by 3. The first term has x2 and the second term has x3, so x2 is the lowest. There is not a y in both, so I can't take that. And both terms have a z to the second power, so I just took all of it. Now let's look at problems where we're going to factor out the GCF and not just figure out what the GCF is, but also figure out what remains after we take it out. So for this, I'm going to recommend that you use an area model. So here I had 3 terms. I'm going to put 3 boxes. We're going to factor out a single monomial, so I'm only going to make my boxes 1 tall. In future lessons, we might have more than 1 row of boxes. So for this, I'm going to place each term in its own box. And then I'm going to factor out my GCF onto the left. So I'm going to work left, and my greatest common factor I'm going to write on the left side once I figure it out. So when I figure out my GCF, it would come out to be negative 3. I can take away 3 from each term, but I can't take an x. And since our first number is negative, my GCF is also negative. Now, how this works to factor it out. you are going to figure out what you had to multiply by in order to get the number in the box. Okay, to do this, you're essentially dividing. So, -3 divided by -3 is 1. And then I didn't have an x to divide the x to the 5th by, so it's still just x to the 5th. +9 divided by -3 is -3. And again, there's no x, so it's still just x squared. And then finally, -18 divided by -3 is +6. So I was figuring out what I needed to multiply by originally, but I did it by dividing. To write our final answer here, we are going to take our GCF out front of parentheses, and then whatever we end up with on top, we put it inside parentheses, and that is our final answer. So it would be -3, set of parentheses, x to the 5th minus 3x squared plus 6. Now it's your turn. Pause the video, factor out the GCF from this polynomial, write it with your GCF out front and your quotient inside the parentheses. Let's check. You should have got -8x as your GCF, and then x to the 3rd minus 10x minus 2 inside the parentheses as your quotient. If we look, our original polynomial is inside. Our GCF is 8x, and it's negative because the first term was negative. And then in this example, we see when we divide -8 by -8, we get 1. 80 divided by -8 is -10. 16 divided by -8 is -2. But here, since we took out an x, we need to divide all of our variables by x. So x to the 4th divided by x is x to the 3rd. If you remember back when we were learning about exponent rules, dividing with the same base means you subtract the exponents. So x to the 4th divided by x to the 1 is x to the 3. X squared divided by x is just x. And x divided by x is 1, so it disappeared. So you should have ended up with -8x as your GCF and x to the 3rd minus 10x minus 2 as your quotient. In this lesson, we learned about the greatest common factor, or GCF, of a polynomial. It's the largest value that you can divide out of each term, and it includes both the coefficients and the variables. And you need to think about both when you're finding the GCF. You might be able to divide by a number, but not a variable. You might be able to divide by a variable, but not a number. Or you might be able to divide by both. If that first term of the polynomial is negative, you also need to remember that you have to factor that out, and your GCF will be negative. When you're factoring with the greatest common factor, think of it as undoing multiplication with a monomial. You are really just dividing, but place the polynomial in boxes, figure out your GCF, then figure out, once you took the GCF out, what did you have to multiply by to begin with to get that polynomial that was in the boxes. So we looked at it as division. Figuring out what to multiply by is the same. When you factor out the GCF, it does give you an answer in the form of the GCF out front, and the quotient is left in parentheses. After this lesson, do you now know how to determine the greatest common factor from the terms of the polynomial? And do you know how to factor out the GCF from polynomials and write it in factored form? If you're not sure about the first one, go back and look at the first two examples. If you're not sure about the last one, look at the last example we did. And hopefully it will make more sense the second time through. You need to have a strong understanding of how the GCF works in order to be successful in future lessons. So if you're not sure about those things, go back and look. And that's the end of lesson 4 on greatest common factor.